Mic check.
Man, I don't understand anything.
Yo, Nas, what's your problem, dude?
I don't understand differentiation, man.
Yo, chill. I got you. Let me explain to you about differentiation.
Alright, let's go.
So, first, the meaning of differentiation is the process of finding the rate of change of the function with respect to a variable. So, here we have some of techniques of differentiation. So, the first one is constant. This is the derivative formula. And the second one we have our, you know the third one is?
Oh, I think the third one is called a product rule.
Yes, correct.
Alright.
Okay, so let's we see the next question. So we jump to the second question of Q&A. So the question is y equal to 5x cubed times e power cross x. So the first step is we have to separate our variables. So I use power rule for u and u prime. I use power rule to get u prime and chain rule to get p prime.
I want to ask something. Why is the v prime equals x multiplied by negative sin x?
Okay, for your information, I use derivative of cos x equal to derivative sin x. Yes. So for the second step, I use product rule. So this is the formula of product rule. Y equal to c multiplied by u prime plus u multiplied by v prime. So I combine all of the variables to this formula. So after I combine all of these variables, I factorize it to get this answer.
Alright, so let's continue to the next question. So here we got f(x) equal to ln 5x over sin 2x. So here I put ln 5x minus ln sin 2x. So what? Do you guys remember what does log x over y equals to?
Log x minus log y.
Yes, correct. Log x minus log y. So here we find here. So ln 5x minus ln sin 2x. So after that, what do we do? We separate. We separate for both ln 5x and ln sin 2x. So in here we got d dx ln 5 plus d dx ln x. So as we know, ln 5 is a constant. So in constant rule, what does it say? Constant rule? Any constant equals to 0. Yes, correct. So we put ln 5 equals to 0. And on the whole ln x, we put 1 over x. So it equals to 1 over x. So here we move on to ln sin 2x. So as you know, sin 2x equals to 2 cos 2x over sin 2x. And cos 2x over sin 2x equals to cot 2x. So we put 2 cot 2x. And then we get back from here, we are supposed to make f prime x, right? So 1 over x minus, remember minus here and minus that, 1 over x minus 2 cot 2x. That's all.
Moving on to the third question. So the third question given is y sin 2x minus ln 2y equal to 2 cubed plus 3. So we need to differentiate the equation by using the method differentiation. So we need to use product rule. This is the formula. So we need to use the equation up there and insert into the formula given. So the second thing is we need to differentiate the second function, so sin 2x by using chain rule. So insert the sin 2x into the chain rule, which is this is the formula which we know d over dx sin 2x equal to 2y cos 2x. So using the equation up there, we need to swap this equation into this one. So the second is we need to differentiate the learn to y by using same method, which is chain rule. This is the formula. So we know that d over dx to y equals to 2 dy over dx. So insert by using the formula. Insert, we can get d over dx then 2y, get 2 dy over dx equals to 1 over y dy over dx. So the next thing is we need to differentiate the right side, which is this one. So differentiate the right side, we can get last answer is 4x. So we need to put everything together, the equation left side and right side, compile it into together, so we get 2y cos 2x is 2x dy over dx minus 1 over y dy over dx and equal to 4x. So the last thing we need to do is factorize or collect all dy over dx into this equation. So we get, since 2x minus 1 over y dy over dx, we need to change this function into the equation, into the right side, so we get this one. So lastly, we need to solve dy over dx, which is we switch to the right, this one, over dy over dx. This is the final answer.
Okay, so for the final question, here is the final question. Formula use change of x and the linear approximation formula. So here is the given value for the function. So all you have to do is 50.98. You have to change it into x, so it becomes basic algebraic method. And then you see here the square roots, we have to get rid of them. So we have to change it into exponent. Here is changed already. And then you see there is 2 in the numerator, so we bring down 2 and then get multiplied. So this here is to be used in the future for our derivative, for the power rule. Here, for the derivative, you see that for the function that we just had here, we apply the power rule and then you get all of this. Then you see that the exponents are negative, so you bring them down. So here is our f. For this, we just follow the formula used here, which is change of x, 50.98 minus 16. Where do you get 16? The initial value here. Initial value is the closest value to 50.98. So our change of x is negative 0.02. For the final step, we just substitute in the formula used here for the linear approximation, and we substitute all of this. And then we get 3 over 2 plus 3 over 64 times negative 0.02. For the answer is 1.4990625. But they asked for 3 decimal places, so the final answer is 1.499. That's all.
Yo, nice. So, I told you right, differentiation is so easy.
Yeah, it's so easy, man. Come on.
Yeah, so let's go.
Let's go.
In conclusion, differentiation in calculus, they help us to solve problems more accurately and efficiently. Methods such as the quotient rule, the product rule, chain rule, they tend to help us better in differentiating more complex problem in calculus. While differentiation might be a little bit challenging at first, with practice and understanding, it will make it easier, God willing. That's all from us. Thank you for watching.